In this problem, we have the opportunity to calculate the stress in a bar. This is an axial loading with a force of 1,777 newtons, and there's a cross-sectional area given by 1 centimeter by 1 centimeter. And the question is, what is the axial stress, sigma x, in units of megapascals? So to start, let's make another little drawing, which is probably not necessary once you get to doing a lot of these problems, but I just want to illustrate a point. We have this force acting over this cross-sectional area. And when we think about stress, we're now thinking about what is a small force acting over essentially an infinitely small area. So if we were to take the face of this bar, and this would be some type of slice that we make in the middle, perhaps, and we divide it up into a lot of small cross sections like this, we can then bring out one of these cross sections, and this would be the face of, say, maybe that cross section, and think about the stress acting on a 3D element that's inside the bar. So here we have the x direction, which is the same direction that you see over here coming out of this face right here. And we have yz, and we'll say that this has an infinitely small dA, right? So this is obviously not exactly to scale. And then the small portion of this F is coming out of this face, and we'll say that's a really small amount of force, and that's going to be a dF, like we see there. So notice that in order for this element to be in equilibrium, there also has to be some type of small dF on the back side in the minus x direction that keeps this element from accelerating. Now, let's go ahead and do the math. We're interested in sigma x, which is going to be equal to some small force over some small area. And for this problem and many problems, we can approximate this dF over dA as being the overall force on this cross-sectional area. So force and then divided by the entire cross-sectional area. So that would be A times B since it's rectangular. And we plug in some numbers. Now note we want to have a final answer in units of megapascals. So what we might typically do is first convert to pascals and then go ahead and multiply by a factor of 1/1,000,000th to be able to get to megapascals. So here's the first step to get us to pascals or newtons per meter squared. And we see that the centimeters squared here will cancel out with 1 centimeter times 1 centimeter. And then we are able to say that 1 megapascal is 1,000,000 pascals. And what we then see further is that this essentially just becomes 10 to the minus 2 times 1777, right? And the units will change. But when we do this out, we get 17.8 megapascals. Now, I'd just like to take a moment to once again show how we can solve or do the calculation quite quickly in Google. So 17, and you can already see it remembers me being here. So we have 1,777 newtons, and we're going to go ahead and divide by 1 centimeter by 1 centimeter. Parentheses are important. The first response gives us something in pascals, so 17.8 million pascals. And then if we want to go ahead and even be a little bit lazier, we can plug in to a conversion to megapascals, and we get that it's 17.8 megapascals, just like we saw. In Python, we can create a little script to perform this calculation. And just a note, for this script, I think Python, well, as you know, Python doesn't keep track of the units, at least not the NumPy that we're using. And so I think the kind of the basic thing to know is just some little tricks in terms of how to keep track of units carefully, especially when you're given things in units that don't just automatically work out to the units that in which we want the response. So let's see, we have force, and that's equal to 1777 newtons. And so I could write it like that, but of course it doesn't keep the newtons, so I'm going to just put hashtag N, and actually we can probably make this a little bigger so people can see. Yeah, okay, so there we go. And then we have an A, which is equal to 1 centimeter. So I often will go ahead and do the conversion. So I'm going to do 1e minus 2 times that, and that will give us units of meters. And then we have B, which is also equal to 1 centimeter, and we'll just say that B is equal to A, and that will give us units of meters again. And we say we want the sigma x, which is going to be equal to the force divided by A times B, just like that. And this would give us units of pascals. Now, you could write another line to convert it over to megapascals in terms of a variable, but I usually leave it just as it is, and I'll do something more like this, where I say sigma x is equal to, and then when I do call the round function, okay, then I'll do sigma x, all right, and then I'll multiply by the 1e minus 6, and then let's say we round to the first decimal place, and we go ahead and we type in MPa, just like that. All right, and we run that, we get sigma x is equal to 17.8 megapascals. I hope this example is helpful, and have a wonderful day.